This is BYOAI, a production-grade conversational AI automation system built with a microservices architecture. In this video, I will walk through the system architecture and justify my design choices, run a live test of the API processing requests through the ML model, and explain how I used AI tools to build this, demonstrating my build-your-own AI skills. The codebase is split into 3 containerized services. The API gateway on port 8000 is built with FastAPI. It acts as the single entry point for all client requests, manages session-based conversation histories using thread-safe async locks, runs a token bucket rate limiter middleware to prevent abuse, features structured JSON logging for request tracing, and enforces strict input validation using Pydantic models. The ML model service on port 8001 is also a FastAPI application, but dedicated entirely to machine learning inference. By isolating this service, we separate heavy neural network computation from the lightweight API layer. It runs Facebook's BART-large-MNLI model through Hugging Face's zero-shot classification pipeline, classifying user messages into 10 different intent categories in real time without needing any labeled training data. The categories include greeting, farewell, question, complaint, booking, feedback, help, cancellation, status check, and out of scope. The third service is MLflow on port 5000, our experiment tracking server for logging hyperparameters, training metrics, and model artifacts. I chose microservices over a monolith for 3 critical reasons. First, independent scaling. ML inference is compute-intensive while the gateway is lightweight. Decoupling them lets us scale the ML service on GPU instances while keeping gateway instances small. Second, model hot swapping. We can replace the classification model by restarting the ML container without causing downtime to active sessions. Third, GPU isolation. Only the ML container needs the host GPU driver through the NVIDIA Container Toolkit, avoiding heavy CUDA installations across the stack. Let's start the system using the run.bat script. It provides automated startup. It pulls the latest code from GitHub, checks if Docker Desktop is running, and launches it if needed, then prompts us to select the compute device. We select option 2 for the NVIDIA GPU for real-time inference. The script validates GPU detection using a temporary CUDA container, then launches Docker Compose with the GPU override file docker-compose.gpu.yml. Once all health checks pass, the script opens 3 browser tabs automatically. All services are healthy. Let's test the API in the Swagger documentation. The health endpoint confirms the gateway is up and returns its uptime. The readiness check goes deeper, verifying the ML service is reachable and the model is loaded in memory. This distinction is critical for Kubernetes deployments. Now the core feature. I send a chat message. Hello, I need help with my booking. The gateway forwards this to the ML service. The BART model analyzes the text and classifies the intent as booking with a high confidence score. On GPU, each inference takes about 0.05 seconds versus over 2 seconds on CPU. The gateway maintains conversation history per session. The history endpoint returns the complete transcript with intents, confidence scores, and timestamps. We can clear any session using the delete endpoint. Here is the MLflow dashboard. When training or fine-tuning models, every hyperparameter, metric, and model artifact is logged here for comparison and reproducibility across runs. Finally, how I used AI tools. First, architecture design. I described my requirements and the AI helped evaluate monolithic versus microservices trade-offs, select BART MNLI for zero-shot classification, and design API contracts. Second, code scaffolding. The AI-generated FastAPI routes, Docker configs, the ML inference pipeline, and middleware, saving hours of manual setup. Third, debugging. When cold start timeouts caused 504 errors, I described the symptoms and the AI identified the timeout was too short for model loading, then helped implement exponential back-off retry logic. Fourth, DevOps automation. The AI created batch scripts with Docker auto-launching, GPU detection, and health check polling. The key BYOAI skill is knowing what to ask and how to validate the output. AI handles scaffolding while I make the critical architectural decisions and ensure everything works end-to-end. That concludes this demonstration. Thank you for watching.